really a golden rectangle, when you create a square, will leave you another golden rectangle. So if I go ahead and make a square out of this one by measuring this amount here, because a square has equal sides, I can now cut off another square. And when I cut off this next square, you're going to see another rectangle is left, and that's another golden rectangle. So if I do that process repeatedly, I can make another square with this new golden rectangle. And again, it's going to cut off another golden rectangle here. We can continue this process. In theory, you can do it indefinitely, but obviously it gets smaller and smaller, so really, you can't do it infinitely. And we can just continue to cut off a golden rectangle. And when we take this shape, we can create what we call the Fibonacci spiral. And we'll use quarter circles to do that. So let me show you how we're going to do that with our compass. I'll just make this final one here. And well, might as well do one last little tiny square here. Now, if I was really making this for myself and not just to demonstrate, I would be a lot more careful to make sure I don't make any minor mistakes. We then take our compass and we're going to use quarter circles. So we're going to use the length of the first square with our compass, and we're going to draw a quarter circle. It'll go from edge to edge, from corner to corner. Then where we leave off, we're going to continue, but we need to adjust the compass to the second square. And then we go to the third square, and we just repeat that process using quarter circles. And as you see, what we'll develop is our Fibonacci spiral. So, making the golden rectangle is quite simple if you can make a square. And I do have a video showing how we make our square, but let me go through the basics and through even some of the math proving that it's going to give us the number 5. So we can do this using a compass, and I have videos on that if you want to use a compass to make a square, but I've gone and made the square already. And I've also found the midpoint. You can use a perpendicular bisector with your compass. That's also a video in case you'd like to do it strictly with a compass. So we start with our square, and we're going to cut it in half and create a line here. And the interesting thing is the diagonal of a square gives you radical 2. But when you take half a square and get the diagonal, it's going to get you radical 5 over 2. So we're going to use this amount here. Now, when we use our compass, it allows us to draw that same amount as a curve. So anywhere touching that curve is going to be the same distance, the same amount. So this line here is going to be the same distance anywhere touching. So if I use my ruler, I can go from here to here and extend it, and that's going to give us our golden rectangle. And I could do the same thing here on top as well. So let's take a look at the math behind it when we're done. We have our golden rectangle, and we have our original square. So let's look at the math behind it. The math behind it, you will need to know how to do the Pythagorean theorem. So if we have the starting square as 1, that means when we cut it in half, here is 1/2 and 1/2. Okay, but we're going to just leave this one here. We won't worry about this one here because we're going to measure this whole amount, not the half. So this red line, we want to prove it's going to give us square root of 5 over 2, because the number 5 is a number that's a ratio related to the Fibonacci sequence. It's dividing it backwards, and it's the square root of, or I'm sorry, 1/2 plus the square root of 5 over 2. That's a way to write it as a fraction. Okay, we also have it as a decimal, 1.618, but the decimal continues. So we already have our half here. We need to prove that this here is the square root of 5 over 2. Let's do the Pythagorean theorem for that. Actually, we will need that half. So the Pythagorean theorem says that this side squared plus this side squared, the two sides touching the right angle, is equal to the third side, the hypotenuse squared. So 1 squared plus 1/2 squared is equal to the hypotenuse squared. 1 plus 1/4 is equals to x squared. If we turn 1 into 4 over 4, so we can add the fraction, we're going to get 4 plus 1, or 5 over 4. And our last step to get x alone is to square root it. So we have the square root of 5, and then the square root of 4 is 2. So this amount is square root of 5 over 2. Anywhere touching this arc is the same amount, which means from here to here, this entire amount is the square root of 5 over 2. From here to here is the square root of 5 over 2. So we have this amount, I'll use green, is 1/2. And this red amount is the square root of 5 over 2, or phi. So those are the constructions of how to make the golden rectangle, as well as the math showing that it gives us 1/2 plus square root of 5 over 2, or we could write it slightly differently. We could write it as 1 plus square root of 5, all of it over 2. So let me show you how we get the Fibonacci sequence very quickly, and how we get the number phi by dividing backwards from the sequence pattern. The Fibonacci sequence pattern is very easy. You start with 0 and 1, and you add them. 0 plus 1 is 1. And you continue the pattern by adding the previous 2. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 3 plus 5 is 8. 8 plus 5 is 13. 8 plus 13 is 21. 13 plus 21 is 34. And you continue adding the previous 2. And the number phi, when we look at it as a decimal, is in some ways like the number pi. It's a decimal that's infinite, and so there's no end to it. It's not a repeating decimal, and it's a ratio. It's a comparison of two things. Now, the number phi is written like this as a symbol, is 1.61803398887, and it continues. So the number phi, it's 1.618,033, and again it continues. So how can we get that from this number pattern here? Well, we can't really use the first few numbers in the sequence, because when we divide backwards, so 1 divided by the one before it is going to give us 1. 2 divided by the one before it gives us 2. 3 divided by the one before it is going to give us 1.5. 5 divided by 3 is going to give us 1.666. So now we're getting closer to the 1.6 number we need for phi. So the first few numbers aren't going to get you close, but if you go farther and farther, so let's use these two. If I take 377 divided by the one before it, I'm going to get 1.618025, and it goes on. And see, the number phi is 1.61803, and it's pretty close, 6180. So let's try one that's further down. How about these two? 1597 divided by 987. And you're going to see we get closer and closer to the approximation of phi, because 1597 divided by 987 gives us 1.6180344. So the number phi is 1.61803398887, and it keeps going. So we have it up to here. We have this pretty good accuracy. I mean, for practical purposes, when you're building something, it's probably close enough. But just to give you a demonstration of how we approach the number phi, by taking the numbers in the Fibonacci pattern, and the further along the pattern we divide the one before it. We compare the one 1597 to the one before it. And that comparison starts to get closer and closer to phi the further and further along we test.